All right, ladies and gentlemen, welcome back. We're looking at part two of our introductory unit. We looked at some of the conversions already in class, so now we're just going to be building on something called the SI units, which basically just means the international units that are accepted in science. So first of all, we're just going to start by looking at some of the units, then we're going to talk about the one-step conversion. So first of all, these are our main units that we're going to be using and looking at. So we have length, mass, volume, time, and amount and substance. The major unit for length is going to be meter, and our abbreviation is M. Mass is going to be grams, it's G. Liters is an L. Seconds is an S. And mole, which is the amount of substances in chemistry, we are going to abbreviate MOL. And that's it, because that extra E on there would have just been too much for us to add. So what we call these things are the base units. These are the standard unit that we're going to be referring to, but we can change each of them by adding a prefix. And we'll scroll down here so you can see all the different prefixes. Each prefix represents a certain equivalent in terms of exponent. So giga, which is a capital G, is times 10 to the ninth, which basically means a billion. Mega is a capital M. Kilo, deci, centi, milli, micro, which is this kind of U-looking shape. You might have seen it in physics before, coefficient of friction. And these are all the necessary exponent equivalents. So you might want to pause that just to get that part down. So what we're going to do with these things is we're going to apply them in terms of a conversion. If we want to go from one to the next, we have to use certain conversion factors, which we'll talk about in a second. So first of all, the most important things that you need to make sure that you do in order to be successful is number one, always include units. Number two, always cancel units. And number three, the prefixes never go beside the exponents. Okay, they're never going to be beside each other, and you'll see what I mean in a minute. So let's look at an example here. If we have 5 kilograms, the whole point of this is we want to be able to convert it into grams. And some people can do these in their heads. But what we're going to do is we're always going to set it up the same way, because this type of question is going to be paralleled when we actually get into the real chemistry stuff. This is still just math. So if we want, we have these conversion factors. We know that 1 kilogram, if we look back up, the prefix K for kilo represented by 10 to the 3. So what we have is that 1 kilogram is 10 to the 3 grams. As you can see here, by changing it from kilograms into grams, we're going to have 5 times 10 to the 3, which is 5,000 grams. So in order to make sure that we have it set up right, the reason why I knew kilograms would go on the bottom is that we know in math is if there's the same thing on the top and the bottom, it's going to cancel. So our goal is to get out of kilograms and into grams. The only way we can do this is by canceling those units. So let's look at another one here. And if you think you got this already, zoom on to the next one. So 46.0 liters. We want to get it out of liters into nanoliters. So what you should be thinking is, what do I need to put on the bottom in order to cancel? Liters are always going to be canceling by putting the top and the bottoms the same, and we want to get it into nanoliters. Well, we know if we look back up here that nano is 10 to the negative 9. So if we look, we just said that prefixes never go beside the exponents, so that's why that 10 to the negative 9 has to go here. So when we put this into our calculator, we're going to get 46 divided by 10 to the negative 9, which is going to be 4, 6, and 9 zeros after it. For people that have done scientific notation, all we have to do is put the decimal with one digit in front of it and go and count the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that would be nanoliters. Okay, and last one, 18.2 millimeters. So if you think you got this one, pause this now and try this on your own. So seriously, pause it right now. And I hope you already stopped it. Otherwise, you're just listening to me do the question anyways. Okay, so we want to make sure we don't have the prefix and the exponent the same line. So little m is going to be -3. So there's going to be 10 to the -3 in 1. Another way that I always remember it is that this and this are the exact same thing. They're both meters. This milli means a certain something, just like this 10 to the -3. These are equivalent, and that's why we can have them on the top and the bottom. It's basically like multiplying this by 1. So it doesn't change anything to the actual number, just a little bit with the value. Okay, moving along into the multi-step, it's going to be the same thing, but the most important rule is this. You always, oops, if I can spell, always go back. Always go back to base unit. And what that means is you always go back to what these ones are. Okay, so if it's nanoliters, always go back to liters. So let's look at this. So what we have here is we're going from centimeters to micrometers. If you notice here, they both have the same base, but they have different prefixes. So this is a multiple step, because what you have to do is you have to change it to meters first, and then from meters to micrometers, because we don't have a way to get straight from centimeters to micrometers. So let's set this up. We're going from centimeters. We know that what has to go on the bottom is centimeters in order for it to cancel, and then we need to go into meters first, but that's not our end goal. What our end goal is to micrometers, so we got to get rid of meters because they're going to cancel, and go into micrometers. So what we did there in terms of canceling our units, centimeters cancel off, meters cancel off, and our end unit is going to be micrometers. And then now all we have to do is fill in the exponents. In 1 centimeter, that's 10 to the -2 meters. 1 micrometer, 10 to the -6. Reminder, as you can see, the prefix always just gets the 1, and then the thing with no prefix gets the exponent. So again, you can go on and look a little bit ahead and try this one out on your own. So pause it now, try this one out. So we're going to get it out of nanoliters by canceling it, putting it on the bottom, into liters, out of liters, because that's not where we want to finish up, and into milliliters. And they're going to cancel off, and then we can put our units in. 1 nanoliter is 10 to the -9. 1 milliliter is 10 to the -3, and then we get our answer. I guess I should do the math for this. So we're going to get 5 times 10 to the 4, which will be 50,000. And we'll talk about scientific notation in class. And this one will be 16.0 times 10 to the -12, which will be 1.6 times 10 to the -11 milliliters. Okay, so we might end up chunking this into 2 depending on how we're doing here for time. Yeah, so we're probably going to stop here right now, and I'll come back with part 2 of this for next day. Okay, have a wonderful night.